lattice and motif. In this video, we are going to discuss further terms related to the crystal geometry.
Let's begin with the lattice translation. To understand this concept, I am going to take a simple square lattice. Previously, we have seen that lattice is a periodic set of points in a space. So, here I am going to draw a periodic set of points in a two-dimensional space, and accordingly, we can call this arrangement as a two-dimensional lattice. Now, in this lattice, I am going to draw a vector from one lattice point to the next lattice point in a horizontal direction. And this drawn vector, which is in black color, is nothing but a lattice translation. If you look at the drawn lattice, it is evident that the drawn lattice contains many points. So, if you wish, you can draw another vectors like I have drawn in red, green, orange, blue and purple color. All these vectors are lattice translations, and lattice will have many such translations. Now, I am going to define a unit cell. For this, I am going to generate a periodic set of points once again. All the points of this two-dimensional periodic set are at a well-separated distance, and I am going to connect these points together. By doing so, I have generated a simple geometry, and if I will repeat this geometry through the lattice translation in a two-dimensional space, I will end up in getting the entire lattice or a crystal. This connected region of a space is called as a unit cell. Thus, we can define unit cell as a connected region of a space which can generate the entire lattice or crystal by repetition through lattice translation. More commonly, we have a square or parallelogram type of unit cell in 2D and cube or parallelepiped in 3D. However, a given lattice can have many different unit cells. Let's find out the different unit cells of a lattice, for which we have to generate a two-dimensional lattice once again. In this lattice, I am going to draw a unit cell. I have drawn a black geometry, and we can call this black geometry as a unit cell as per our earlier discussion. In addition to this square unit cell, we can generate one more unit cell in the same lattice. So, here I have generated a parallelogram in a red color. We can call this red entity as a unit cell because if we will repeat this parallelogram through the lattice translation, we will get the entire lattice or a crystal. If you wish, you can generate a unit cell which is bigger than the earlier unit cells. For example, the unit cell which is drawn in a green color. If you will observe all these drawn unit cells carefully, you will find that in red and black unit cell, the lattice points present only at the corners. Whereas in case of green unit cell, the lattice points are at the corner as well as at the center of a unit cell. Based on this, we have two common types of unit cells, namely primitive type and non-primitive type. In primitive unit cell, lattice points are at the corner, and in non-primitive unit cell, these points are at the corner as well as at some other places, and a lattice or a crystal have many different unit cells, and this is called as non-uniqueness of a unit cell. Now, we are going to understand the crystal coordinate system. So, let me draw a set of points and a unit cell. Once we have selected our unit cell, we can define it by vectors along its edges. So, select one of the corner of this unit cell as an origin and mark the axis x and y. Now, we will mark the vectors from the corner along the unit cell edges. Accordingly, A and B became vector in this case and OXY forms the crystal coordinate system. If we wish, we can also select another unit cell. So, here I have drawn the parallelogram and now I am going to mark the axis, origin and vector A and B for this new unit cell. In case of black unit cell, vector A and B are equal and angle between these two vectors is 90 degree. Whereas in case of red unit cell, vector A is not equal to vector B and angle between these two vectors not equal to 90 degree. From this, we have understood that crystal coordinate system can be Cartesian or non-Cartesian. Let's understand the lattice parameters. For this, I have taken a cubic unit cell. Now, I am going to select one of the corner of this unit cell as an origin or a reference point. Let's indicate the axis x, y and z. Now, I am going to mark the length of unit cell edges along each axis. Thus, A is a length of unit cell edge along x-axis, B along y-axis and C along z-axis. Let's mark the angle between these edges. So, alpha is an angle between A and B, beta is an angle between B and C and gamma is an angle between A and C. The lengths of three edges of the unit cell and three interaxial angles between them together called as lattice parameters.